Math 83, Unit 3, Lesson 3. Write a number in scientific notation to standard notation, or another name for that is decimal form. A number is in scientific notation if it's written in the form a times 10 to the n power, where n is an integer, that's up here, and a is greater than or equal to 1 but less than 10, and that's this number here in front. So that means that a can be 1 all the way up to 9.9999999. Just has to be less than 10. So if we look at number 1, we're going to take 2.56 and we're going to multiply it by 10 to the second power. Well, that just means we're going to take the decimal point that's there and move it to the right 2 places, and that's where the new decimal is going to go. And I can rewrite this now as 256. So 2.56 times 10 to the second power in scientific notation goes to 256 in standard notation. 1.7 times 10 to the 8th, we're going to write down 1.7 and we're going to move that decimal point 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to fill in all those spaces with zeros. Now the decimal point is now right here at the end of the number. So I want to rewrite this now. 17 with 7 zeros, 1, 2, 3, 4, 5, 6, 7, and then we'll put commas in. Now both of those numbers had positive powers, so each time we're taking the decimal point and moving it to the right. Now we're going to look at 1, and that's going to go, the decimal is right here at the end when it's not in the number, it's right at the end of the number. And positive 6 power means we're going to move the decimal 6 places to the right. 1, 2, 3, 4, 5, 6, and that's where the new decimal is going to go. And then we're going to fill in those places with 0. So our final answer is a 1 with 1, 2, 3, 4, 5, 6 zeros. Well, that's 1 million. So the first 3 problems all had positive powers. So each time we were moving the decimal to the right. And all of these were very big numbers. Now we're going to look at what happens when we have a negative power. So I'm going to write down 2, and the decimal is right at the end of the number. And since we're multiplying by 10 to the negative 2 power, that means we're going to move the decimal to the left 2 places. 1, 2, and it's now going to belong right there. And we're going to fill in that place with a 0. So this becomes 0.02, and it's customary to put a 0 in front here in the ones place. So we have 0.02. So you can see with a negative power, we're going to have very small numbers. We're going to take 4.3. We're going to move the decimal to the left 4 places. 1, 2, 3, 4, and that's where the new decimal is going to go. We fill in those places with zeros. So we have 0, 0, 0, 4, 3. You can see a negative power on my scientific notation is going to be a very small number. 6.63 times 10 to the negative 5th power. Again, we have a negative power, so we're going to take this decimal point, we're going to move it 1, 2, 3, 4, 5 to the left. We're going to fill in those places with zeros. And we're going to rewrite the answer as 0.0000663. Now we're going to write a number that's in standard notation or decimal form to scientific notation. So here we have the number 8 million, and the decimal point is at the end of the number. And so we want to move it all the way to here so that it's right after the first number that's not 0. And we're going to rewrite this as 8 times 10, and we moved it 6 places to the left, so it's going to be a positive 6. So 8 times 10 to the 6th power. Again, a really big number is going to have a positive exponent. And we recognize that this first number has to be greater than or equal to 1, but less than 10. 567,000, the decimal is at the end. We're going to move the decimal right in between the 5 and the 6, and we're going to rewrite this as 5.67 times 10, and we move the decimal 5 places to the left, so this is going to be a positive 5 power. Again, I look at this as a big number is going to have a positive power when it's in scientific notation. We're going to take 100, decimals at the end, we're going to move it to the left 2 places, so that's going to be 1 times 10 to the 2nd. Now this time we're going to be moving the decimal point in the opposite direction. It's right here in the number, and we need to move it to after the 6. So I'm going to rewrite this as 6 times 10, and I move the decimal 4 places to the right, so that's going to be a negative 4 power. Again, really small numbers are going to have negative powers when they're written in scientific notation. We're going to take the decimal and move it between the 7 and the 6, and we're going to have 7.6 times 10. We move the decimal 6 places to the right, so it's going to be a negative 6 power. Again, small number, negative power. We're going to take the decimal, move it to the end here, right after the 3. We moved it 2 places to the right, so that's going to be a negative 2 power. We have 3 times 10 to the negative 2 power. Now we're going to multiply and then write the answers in scientific notation. So we can go ahead and multiply the 2 and the 2 and get 4. And then with 10 to the 3rd times 10 to the 5th, we just need to add the powers. So that's going to be 10 to the 8th. This is already in scientific notation because the first number is greater than or equal to 1 but less than 10. And so our answer is 4 times 10 to the 8th. Now we can multiply 7.5 times 8.8. We can do that on our calculator if we like, and that's going to give us 66. And then we're going to take, with our base of 10, 10 to the negative 7th power times 10 to the negative 4th power. We can add those exponents and get negative 11. Now this number, 66, is not greater than or equal to 1 but less than 10. So now we need to rewrite this in scientific notation. So looking up here, we're going to take the 66, there's a decimal at the end, and we're going to move it 1 place to the left, and that 66 becomes 6.6 times 10 to the 1st power. And then we're going to have the rest of this times 10 to the negative 11th power. So now we have to combine those two. So this becomes 6.6 times 10, and we want to add 1 and negative 11, and that's going to be negative 10. So our final answer in scientific notation is 6.6 times 10 to the negative 10th power. Now here we want to determine the power of 10 needed to write each of the decimals in scientific notation. So as we can see here, the decimal would have been at the end, and it moved between the 3 and the 5. And we need to figure out what this integer a would be to turn it into scientific notation. Well, because we moved it 4 places to the left, our power on 10 will be 4, so a is going to equal 4. Next problem, the decimal's at the end, and it moved right in between the 4 and the 3. So our integer b is going to be 6 because we moved the decimal 6 places to the left. Our decimal here moved between the 7 and the 0. Now this is a very small number, so we're going to have a negative power that's going to go in place of c here. We moved it 3 places to the right, so that's going to be a negative 3. We're going to take this decimal here and move it between the 2 and the 0. It's a very small number, so it's going to have a negative power, and we moved it 6 places to the right, so d is going to be negative 6. Number 19. Which of the following is 100 to million in scientific notation? Well, the decimal is here at the end, and we need to move it right in between the 1 and the 0 and get 1.02. This is a really big number, so we're going to have a positive power, and we move that decimal 8 places to the left, so we're going to have a positive 8 power. So our answer is E. Which of the following is the standard form for 6.8 times 10 to the negative 4th power? We're going to take 6.8. Negative 4th power means it's going to be a small number, so we're going to move our decimal to the left 4 places, 1, 2, 3, 4. And we're going to fill those spots with zeros. So our answer is D.